Yes, today we're going to see the problems on Thevenin's theorem. Before that, we'll see what it states. Okay, before Thevenin's. THEVNS Thevenin's theorem. Okay, first of all, Thevenin's in the sense first, what I'm going to get in my mind that VTH and RTH. Okay, here Thevenin's theorem states that any combination of linear bilateral circuit elements and active sources, whatever the complexity of the network, okay, connected to a given load, that is ZL, may be replaced by a simple two terminal network. That means here whatever the complex network will be replaced by two terminal network with the internal source RTH and the load ZL or RL. Okay, where any two terminals of the network can be replaced by an equivalent voltage source. This is the equivalent voltage source and an equivalent series resistance. Okay, the voltage source is the voltage across the two terminals with this. It means I am going to calculate the VTH by removing this ZL. Means I am going to see my voltage from these two terminals, that is VTH. Okay, now we'll proceed with one simple example, then we'll get to know here. Okay, this is my network. Okay, while solving the problem, only we'll see what are the steps to be followed in a Thevenin's theorem. Okay. And the limitation of this Thevenin theorem is it's only applicable to linear elements. It means for capacitors, inductance, this Thevenin's theorem is not applicable. Okay, now here this is given as 5 ohm, this is given as 20 volt, this is given as 2 ohm, 10 volt, 40 volts. Here we, the circuit what I have drawn here is only a linear elements with some voltage sources. Resistance is a linear or non-linear element?
Linear.
Linear. What is the definition for linear? The characteristics of that element will not change with the voltage and current. A simple way, temperature independent. Diode is a linear or non-linear? Sorry, temperature independent, current and voltage independent. Okay. Is linear or non-linear?
Linear, sir.
Linear.
Yes, sir.
Then tell me any some non-linear elements. Examples.
Capacitor and inductance. No, sir.
Okay, we'll come to that later. Now first, limitation of Thevenin's is not applicable to the circuits consist of non-linear elements. Second one, not applicable to unilateral networks. Okay. there should not be a magnetic coupling between the load and the circuit to be replaced by a Thevenin's theorem. Okay, now see here, first of all, find the current through 2 ohm resistance. The question is given as find the current through resistance. This 2 ohm resistance. First step, we need to consider this 2 ohm as our load. If in question, if they ask to find the 5 ohm, then I need to consider 5 ohm as my load, that is RL. Here they ask find the current through 2 ohm, that is here RL is 2 ohm. Okay, for that what I need to here, first I will replace this with the open circuit. This is my RL now, 2 ohm is RL now, so I am going to replace this one with open circuit. See here. This is 40. This is 20 volt. For you, 10 now. Here this one, I'm going to call this terminal as A, terminal as B. We need to calculate phi TH. Here, phi AB is my phi TH. Whenever I'm going to see or calculate the voltage source from this load terminal to be opened, here 2 ohm is the load of the circuit. Whenever they are going to ask the current through 2 ohm, in the sense I'm going to consider this one as my load RL. If in the question they ask current through 10 ohm or 5 ohm, if 10 ohm, in the sense I'm going to consider this one as RL and I have to be open this. Now due to this, how many loops are there? First tell me, in this network how many loops are there?
One.
Only one loop is there. Why? Circuit. Okay, one loop. So I'm going to mark my loop current in this direction, that is I, current I. This is not a loop because I opened this 2 ohm resistance. Okay, now I'm going to apply KVL for this loop. Apply KVL for loop, this loop. First I need to mark current entering point plus minus, current entering plus minus. Yeah. Now tell me, plus to minus, potential gain plus 40, plus 40, then plus to minus, potential drop minus 5,
minus 5i,
minus 5ui, then
minus 20,
minus, then
minus 10i is equal to 0.
minus 10 equals to 0. Okay, now tell me from this, calculate the value of I. I equals to minus and 15i and 20. 15i equals to 20, then I equals to 1.33 ampere. If I solve this equation, 40 minus 5i minus 20 minus 10i equals to 0, I'll get I equals to 1.33 ampere. Okay, now calculate phi TH. Now I know current passing through this 10 ohm, I equal to 1.33. Okay, then consider this path. This consider this path. Okay, tell me the equation. See here. 10i plus to minus minus VTH minus VTH, then minus to plus minus 10, correct?
Plus 10, sir.
Minus
10, sir. Plus 10.
plus 10 is equals to 0. We know I is 1.33. 10 into 1.33 minus VTH plus 10 equals to 0. VTH is equals to how much? Ten into 1.33, this is 11.33 plus 10, that is 23.33. 23.33 volt VTH. Fine. Now next step. Here first step what we did, we consider this 2 ohm as a load resistance. We removed this load resistance, and by seeing from this terminal after removing AB, we calculated VTH. Now we need to calculate RTH. Okay, for that, for RTH we need to replace voltage sources with their internal resistances. Here how many voltage sources are there? First see here, how many voltage sources are? 1, 2, 3. 3 voltage sources are there. So we need to replace these voltage sources. Okay, circuit, the internal resistance is, so we need to replace these voltage sources with short circuit. If in place of this voltage source, if we are having the current source, I am going to replace with the internal resistance of that current source. If not given, I am going to replace that current source with the open circuit. Voltage source with the short circuit, current source with the open circuit. Okay, after that I'll get my circuit like this. If I'm going to replace this 40 volt with the short circuit, 20 volt to the short circuit. Okay, then 2 ohm RL circuit, means we are going to calculate the RTH by seeing from the load resistance RL. Okay, here in this question 2 ohm is RL. Okay, this is 5 ohm, then this is 10 ohm. 40 volt short circuit, 10 volt short circuit, 20 volt short circuit. Okay, now tell me, by seeing from this end AB, these 5 and 10 ohm are in series or parallel?
Parallel.
How? Yeah, because current is simple. How we are going to say this is parallel, this is series? Wherever if 2 or 3 resistances or any elements in the circuit, if current is dividing into them, then we can say it's a parallel. 5 and 10 ohm are in parallel. Okay, 5 in parallel with 10. Yeah, tell me, 5 ohm in parallel with 10, how much? R1 R2 divided by R1 plus R2. Tell me.
3.33.
Yes, 3.33 ohm. This is my RTH. RTH. Okay. Now, after calculating VTH and RTH, I need to replace the circuit with the which considering VTH and RTH and the load resistance. Okay, now see here. VTH is 23.33. Okay. Now equivalent circuit, that is Thevenin equivalent circuit. Okay. Thevenin equivalent circuit. VTH is how much? This is VTH. This is RTH. Okay. And this is my load resistance. Tell me. RL, RTH. What is how much? Yes.
2 ohm.
2 ohm. RTH is 3.33. VTH is 23.33 volts. This RL is 2 ohm because in the question they ask current through 2 ohm. We need to consider this 2 ohm as a RL, my load resistance. Okay, now I need to calculate the current in this loop. That is the current flowing through the load resistance. I'm going to call it as IL. I need to calculate IL. IL, tell me, IL equals to RTH and RL is in series. So VTH divided by RTH plus RL, that is 23.33, 3.33 plus 2. Yeah, I'll get IL is equals to how much?
4.37.
4.379, that is 4.38 ampere. Ampere. Okay. Now listen carefully. Steps to be followed in Thevenin's theorem. First, remove the load resistance RL. Here in the circuit, 2 ohm is the load resistance. We remove that one. Then find the open circuit voltage VTH. If by removing this 2 ohm, this will be open circuit VTH we have to calculate. Then RTH from point A and B. If I remove this, okay, this is point A, this is point B. We need to calculate VTH and RTH from seeing from this A and B point. Okay, now replace the network by a voltage source VTH. Replace the network by voltage source VTH and in series with RTH. Okay, and find the current RL, IL through RL. That is IL equals to 4.37. Total 3 to 4 steps are there. First, we need to remove the load resistance, find the open circuit voltage VTH, find the resistance RTH from A and B points, then replace the network with VTH in series RTH and load resistance, calculate the current flowing through load resistance RL, IL, that is 4.37. These are the steps to be followed. Okay, now we'll see another simple example on this. This is understood, right? Everyone understood, right? Thevenin's, yes?
Yes, sir.
Yeah.
Yes, sir.
Now we'll see another simple example. Yeah. Obtain the Thevenin equivalent of the network between terminal X and Y, and also find phi naught. Okay. On circuit voltage, output voltage of V naught. Here the circuit is given like this. Last example, we didn't include any current source. Here we're going to include that one. 1 minute. Yeah. Okay, this is X. This point is Y. Plus minus, we need to calculate this. Phi naught. Okay. This is given as 4 milliampere, 6 ohm, 4 ohm, 3 ohm, 3 ohm, 12 volt, plus minus. Okay, here tell me which one is the load resistance here. See, first I will read out the question. Obtain the Thevenin equivalent of the network shown. We need to obtain the Thevenin equivalent of this network. Okay, between the terminal X and Y. Here terminal X and Y. Also find V naught.
Sir,
Okay, fine. Okay, here tell me what which one is RL, load resistance.
3 ohm.
3 ohm.
Between X and
Okay,
Y.
yeah. Here
between
between X and Y, 3 ohm is my RL, road resistance. Okay, now first step. How many loops are there?
2 loops.
No. In question they given 1, 2, 3, 3 loops. Okay. Now I need to remove this 3 ohm load resistance. They will become 2 loop. Okay, correct. Here I am going to remove this 3 ohm resistance RL with open circuit. Okay, the circuit become X, Y, VTH. Okay, this is 3, 4, 6, 4. We take not milli. Okay, only 4 ampere. Calculation will be easy then. Plus minus. Okay, now in this circuit 2 loops are there. I am going to mark loop currents I1, then I2. Fine. Now I need to mark the potentials. Current flowing here plus, minus, plus, minus. Okay, here plus, minus, plus, minus. Okay, from seeing by visual inspections only we can tell what is the value for I2.
4 ampere.
Yes, the I2 from loop 2, I can say I2 is equals to 4 ampere. Now apply the KVL for this loop. See, first loop, second loop. From loop 2, I'll get I2 equal to, okay, then KVL for loop 1. Yes, anyone? This is plus
12
minus, this is
minus
minus 12, right? No, minus to plus.
plus 12.
12, yeah, 12,
Minus 6. minus 6 I1 minus I2
minus 6 I1 minus I2
minus 3 I1 is equal to 0.
minus 3 I1 is equals to 0. Okay, now 12 minus 6 I1 plus 6 I2 minus 3 I1 equals to 0. That is 12 9 I1 plus 6. What is value of I2? 4 ampere. Correct? 4 equals to now what is the value of I1? 6 into 4 how much? 24 9.
So I1
Okay,
is 4.
I'll get I1 is equals to 4 ampere.
4 amperes.
Yes, I2 is 4 ampere, I1 is 4 ampere. Now we need to calculate the drop across 3 ohm. Here, this 3 ohm. Because we need to find out VTH, right? So we need to find out drop across 3 ohm as well as this 4 ohm. See, whenever I am going to open this RL, there are two terminals X and Y. Okay, we need to find the open circuit voltage by seeing from X and Y terminal. Okay, here this is a path. Okay, where in this path 3 ohm also 3 ohm is there and 4 ohm is there. So first we need to find drop across 3 and 4. Drop across 3 is how much?
3 I1.
Yeah, 3 I1. That is 3 into 4. That is
4.
3 into 4, 12 volt. Correct?
Yes, sir. Next to
Then
4 into
this one,
4 8.
4 I2. That is 4
16.
into 4, that is 16 volt. Okay, now consider this path, X to Y path. Here,
Yes, sir. Minus VTH, sir.
this one, minus VTH plus 12 plus 16
Plus 16.
is equals to what? 0 or
0.
what? Yeah, 0.
0,
Now
sir. 0.
VTH equals to 12 plus
8.
16, minus get cancelled. VTH equals to how much?
8.
28 volt. This is 28. Now next step, we need to find R equivalent, that is RTH, by seeing from this terminal only. For that, replace the voltage source with their internal resistance. If internal resistance is not given, then we are going to make it as a short circuit, and current source with their internal resistance. If not, we need to replace that current source with the open circuit. Okay, now tell me, wait. Okay, I'm going to replace this 4 ohm with open circuit, this one with short circuit. Now I left with 6 4, this is short circuit, this is 3. Okay, with the X Y 4 ohm, 6 ohm, 3 ohm, R equivalent or RTH. Okay, yeah, 6 and 3 are in parallel. Okay, now I can write. Tell me, 6 and 3 in parallel. How much? 6 in parallel with 3? Yeah,
2.
2 ohm. Yes. I'm going to replace the 6 in parallel with the 3 as 2 ohm. This is 4 ohm, X and Y. Now I can write R equivalent is equal to 4 and 2 are in series. So 4 plus 2 is this 6 ohm. R equivalent is 6 ohm. VTH is 28 volt. Okay. Now next step. Yes, guys. Next step. Next step.
Equivalent circuit, sir.
Equivalent circuit.
Thevenin equivalent circuit.
Yeah. Here plus minus RTH, then RL. Sir. Okay. This is RL. See, VTH, RTH, RL. These are terminal X and Y. Okay. RTH is 6 ohm. 6 ohm. VTH is 28 volt. RL is 3 ohm. First we replaced that 3 ohm, right? That is 3 ohm. We need to calculate the current through RL. That is IL. IL is equals to VTH divided by RTH plus RL. IL is 28 3. How much?
3.11.
Yes, 3.11 ampere. Okay. Now, in question they asked the V naught. V naught is equals to, tell me, Ohm's law. RL into IL.
3 into 3.1.
Yes, 3 into 0.11 equals to how much?
9.33.
93 volts. Okay. Fine. Understood? Thevenins. Okay. Now, quickly, we'll see another problem with dependent source. The theorem is simple. Just we need to the steps. Okay. Now, one dependent source. I need to consider this a network. Tell me which type of source is this? Diamond shape inside the current indicated. Which type of source that is? VDVS or VDCS?
Dependent current source.
VDCS, that is voltage dependent current source. Okay. Vx 10 ampere is given as 4. These are two terminals A and B. Find the Thevenin equivalent of the network shown. This is the question. Okay. Yeah. First step. We need to calculate Thevenin voltage, that is VAB. Okay. Before that, we can see if I am going to consider two loops, 1, 2, here, I1, I2. Okay, here we cannot apply the KVL to the current source, correct? Now we need to write the equation for this current source, that is I1 see here, I2 direction and the 10 ampere direction is the same, so we need to take the sign as positive for I2. The direction of I2 is same as 10 ampere and the direction of I1 is opposite to the 10 ampere. While writing the equation for this current source, I am going to write minus I1 because its direction is opposite of 10, then plus I2 is equals to 10 amp. Okay, I'll call this equation 1. Now, by seeing this Vx by 4, this voltage source, okay, this dependent source, I can say I2, see, I2 is equals to, see, always arrowhead is positive, tail of that arrow will be negative. Okay, then I'm going to write I2 is equals to minus plus 2 minus potential drop, okay, minus Vx by 4. I'll call this equation as 2. You can see this Vx in loop 1, Vx is equals to minus 3 I1, that is minus Vx equal to plus 3 I1, that is Vx equal to minus 3 I1. This one, I'll call this one as equation 3. Now I know I2 value minus Vx by 4. Okay, here I2, I'm going to replace this in 3 in 2. That is I2 is equals to minus Vx minus 3 I1 minus 3 I1 divided by 4. Okay, I'll get now minus 0.75 I1 plus I2 is equals to 0. I'll call this one as 4. Now solving equation 1 and 4, solve equation this one, minus I1 plus I2 equals to 10, then minus 0.75 I1 plus I2 equals to 0. Okay, solve these two equations. 2 and I1. I1 is equals to how much? I2 equals to how much? Tell me, quick. Minus I1 plus I2 equals to 10, then minus 0.75 I1 plus I2 equals to 0. To yes, equation is visible, right?
Sir, second equation.
Minus 0.75 I1 plus I2. First equation is minus I1 plus I2 equals to 10. Second one minus 0.75 I1 plus I2.
40, yeah.
I1 is 40,
Minus 40.
minus 40,
Minus 40.
minus
Yes, sir.
40
I1 minus
ampere.
40.
I2
Minus 30, sir.
Minus 30. Okay.
Minus 40, I2 is minus 30.
Yes.
Minus 30.
Yes. After solving equation, this is I'll get I1 as minus 40 ampere, I2 as minus 30 ampere. Okay. Question is what? Find the Thevenin equivalent of this network. Okay. Means we need to find A and B. Here no resistances are given across this A and B. Means we need circuit voltage. So we are not considering this. These are the current sources. We need to find open circuit voltage. So for that we need to trace this part A to B. Okay, here I can write that path as A to B. 5, 3, 3. A. Okay, I can write this is 5 ohm. See, this 5 ohm, this 5 ohm. Okay, then 3, then 3. 3 ohm, then 3 ohm. Okay, I'll write minus, plus, minus, plus, minus, plus. See how I am writing this minus, plus, minus, plus, minus, plus. Current entering into I2, plus, minus. Current entering here, plus, minus, plus, minus. Okay, if I trace this A to B path from A to B, plus the first one is minus plus, okay, then minus plus, then minus plus. See the minus plus, minus plus, minus plus, minus plus. Here minus plus, minus plus, minus plus. Okay, now I can write, I know which current is flowing through this 5 ampere, 5 ohm. Yes,
I2.
I2 is flowing, I2 we know that 30 ampere.
Minus.
Okay, minus into 30 is 150. Okay, minus 150 volts for this. If in this 3 and this 3, current I1 is flowing, then I1 we know minus 40. 3 into 40, 120. Minus 120 volt. Here minus 120 volt. Okay. Now I can write VAB. This VAB is equals to VTH is equals to how much? All three together. 150 plus 120 plus 120. How much?
390.
390. That is minus 390 volts. Okay. Here A is the negative minus 390. If I am going to take A with the positive, VBA VTH is equals to plus 390 volt. With A being negative, this side negative, I'll get minus 390. If A being positive, I'll get plus 390. Okay, VTH is 390. Fine. Now find short circuit. Now we need to short circuit A and B. First I'll delete this one. See here. Now step 3. We need to find R equivalent. Okay. For that, this is the circuit. See here. Okay, 3 ohm. 5 ohm, 10 ampere, Vx by 4, 3 ohm, that is Vx plus or minus. This circuit given, right? We need to find Z equivalent or R equivalent. We know open circuit voltage VTH is, that is open circuit voltage, that is 390 volt. To find ISC, short A and B. We need to short, see, this A, terminal B. We need to find short circuit current, ISC. Okay, here this is I1, this is I2, this is I3. Here I can say I3 is equal to ISC. Now, from this, I have written one equation before, minus I1 plus I2 is equals to 10. Okay, then minus I2 plus I3. Now I am going to consider this. If I short circuit this one, I need to consider I3 also. So I will write minus I2 plus I3 is equals to Vx by 4. That is, I call it as 2. Okay, from loop 1, we know that Vx equal to minus 3I1. Vx equal to minus 3I1. Call it as equation 3. Okay, if I'm going to use this Vx, this equation 3 in equation 2, okay, use equation 3 in equation 2, I'll get 0.75 I1 minus I2 plus I3 is equals to 0. By seeing this circuit, I can simply say I3 is equal to ISC. Now applying KVL to outermost loop. Okay, that is apply, this is equation 4, apply KVL to outer loop. I'll get, see, minus 3I1 plus minus plus minus plus minus. Okay, now minus 3I1, then here 5 minus 5I2. See, one more minus I1, 1 minute. Okay, minus 3I1, then minus 3I1, then minus 5I2 is equals to 0. I'll get 6I1 plus 5I2 equals 0. Call it as equation number 5. Okay, if I'm going to solve equation 1, this equation, see, equation 1, then equation 4, then equation 5, 1, 4 and 5, I'll get I1, I2, I3, where we need to find ISC. ISC, I know ISC equals to I3. After solving those equation, I'll get I3. Okay, here we solve and see this one afterward. Is equal to I3. Then final step, Z equivalent equal to open circuit VOC by ISC. That is 390 divided by, that is ISC is nothing but I3. We'll get some value. Okay, the final step is write, draw the equivalent circuit. Here RL is not given. That's why we are going to calculate short circuit current ISC. Okay, this VTH and Z equivalent or R equivalent. Okay, this is 390. We need to calculate this. We calculate this one, right? No, we need to calculate this. That is A, B. This is the final step. If in the question any load resistance or load impedance is given in the sense, we need to include RL here. If given, I am going to insert this one. If given, here it's not given, so I am considering the short circuit current ISC. This is my Thevenin equivalent circuit.